My dear viewer, I welcome you to our program. Somera Mudirolio. I'm very grateful to meet you this morning. Since Monday I had not met you, it is today, now we are meeting. As usual, Mangen Bernard is my name, from St. Savio, Kisubi, Entebbe there. My dear critical thinker, creative thinker, logical thinker, problem solver, I welcome you to our lesson, mathematics. Let's mathematize this morning, and we see the way forward. We are not going to waste any single minute because of the little time we have. Otherwise, I appreciate whatever you have done. There is a colleague who called me last time about the work we covered last time. He told me, teacher, first number was very okay, second number was very okay, but third and fourth number, I was a bit faster because of time. But I expected it to be a simpler way of handling it. However, if it didn't work out for you, I'm going to peruse it again, number 3 and number 4, before we set off to the new work. Thank you so much for having endeavored to see that you call me and we discuss. The last two numbers, yes, I was a little bit faster because we were left with like 5 minutes. So let's not waste today any single minute. I can give you a review just on number 3 and number 4 because number 1, number 2, they were well performed. Our first number was, my farm has a quarter broilers and a third layers, full stop. That is how the question is. My farm has a quarter broilers and a third layers. Does that mean that those are the only kind of birds which are on the farm? No. It has the farm has a quarter broilers and a third of third layers. Meaning there are other birds. There could be croilers, locals, like that. But the statement continues, and they say, if there are 20 more layers, according to the question, if there are 20 more layers than broilers, because they stated the 2, there were 20 more layers than the broilers. What is the number of the birds on the farm? What's the number of the birds on the farm? So here, they compared the 2. They didn't give us the number of broilers. They didn't give us the number of layers as well. But they gave us more layers which are on the farm than the broilers. Other birds, they didn't talk about them. See that? So, to find the number of birds on the farm, we needed also to match with this number. What fraction matches with the 20 more layers? They compared the broilers and layers, and they said there were 20 more layers than the broilers there. As I stated it, how many birds were on the farm? That is why I said we needed to first find the difference in the number of broilers and the layers. Since they said there were 20 more layers than broilers, it means the fraction of layers is more than that of the broilers. So we just need to know the more parts or the more fraction for layers than broilers. Thereafter, we match. That is how it's supposed to be approached. Otherwise, if they had given us the number of layers, we could do easily assume, let the number of birds be X, then we say a third of all the birds. But here, they gave us, if there are more layers, that means we need also to find more fraction for layers than broilers. I think there I'm a bit clearer. So we first begin by finding the more fraction for layers than broilers. Then we shall match. If we don't match, we can elate. Okay, so we shall have a third, the difference. A third of the birds were layers. and a quarter of all the birds were broilers. But there were 20 more layers than broilers. So we shall get the fraction for layers. Take out the fraction for broilers. We are finding the more fraction for layers than broilers. Let me hope that one is clear. So we proceed and say, this one gives us LCM of 3 and 4 is 12. So the purpose of this LCM, I told you, is to be divided by these denominators, and we multiply by the numerators. Or you can write it in a simpler way. After getting the LCM, get this fraction, a third, multiply it by the LCM. Take away, if you are taking away. If you are adding, you add. Take away, you write your fraction, again multiply by the LCM. I think this one can easily help you. So we reduce this by 3 ones. 3 goes into 12 4 times. By 4 ones, by 4 is 3. So here we shall end up with, when we multiply this, 1 multiplied by 4 is 4. Take away 3 out of 12. I think there it is clear. You can't get lost anywhere here. This 3 divided the 12, and we got 4. 1 multiplied by 4 is 4. Take away this by 4 once by 4 is 3. I think people know this. 1 multiplied by 3 is 3. So we shall end up with 1 out of 12. Now, this is the more fraction for layers than broilers. 12 was more fraction, which was for layers than broilers. Now, we were given the number of more layers than broilers. So this fraction matches with this number. So we shall just say, we can now assume, or we match. I was telling you, this now fraction matches, or is equivalent to this 20 more birds. See that? This is a fraction, this is the number. We can let, or we match. This is one part. Or you can let. I think last time I matched. This time, and it can work. Okay, let's match. We pick only the numerator there, which is a 1. 1 part represents 20 birds now. What if this is already 1 part? What if now all the 12 parts, this is the total. What if now all the 12 parts? 12 parts represent, it will be now 12 multiplied by 20 birds. If 1 part is 20 birds, what if all the 12 parts? You can add 20 12 times, which is the same as 12 multiplied by 20. And we shall end up with 240 birds. If you multiply this well, you will end up with 240 birds. These were the birds on the farm. These were not only broilers and layers, no. There were other birds, but among the birds, they had given us only the fraction for broilers and layers. See that? So I think this one is clearer. Or you can let the number of birds be x. When you get a 12, is it 1 out of 12? Of all the birds on the farm, they give us the 20 more layers. If you have assumed, let the number of birds be x, then you say, when you get a 12 of all the birds on the farm, you will get 20. This is what we say, assuming or you match. But we might prefer this one because it's simpler. Oh, even this one is also easier. It is not bad to know both methods. So when we multiply this, 1 multiplied by x is x out of 12, because 12 multiplied by 1 is 12. Right? With multiplication, we multiply numerator, multiply by numerator, out of denominator, multiply by denominator. That's why I say 1 multiplied by x is x. 12 multiplied by 1 is 12, which is equal to 20. And from there, you multiply both sides by 12, and you will end up with the same answer. So if it is x out of 12 multiplied by 12 is equal to 20 multiplied also by 12. Once. Our x will be equal to 20 multiplied by 12. We shall end up still with, is it 240? Birds. those were the number of birds on the farm. I've just repeated that one because of the request someone or some people made that I was a little bit faster when it came to 3 and 4 because of time. However, I don't want to be again faster for today's work. Let's summarize with our 4. Number 4. Our number 4 was saying the range between a fifth and a sixth of a number. So if you know how to internalize questions, the range, you know what range means. Range is the difference between the highest and the lowest. Range means get the highest, take out the lowest. So they are saying the range between a fifth and a sixth. Do we know the range between a fifth and a sixth? We don't know it. Then they continued and said, of a number is 7. I repeat, the range between a fifth and a sixth. They want the range between this and this. We don't know it. Do we know the range? No. But they are saying the range between this and this. Of a number. The range between this and this. Of, you know what of means? A number which is not known is 7. Now, is stands for equals 7. Find the number. So, we didn't know the range because they were saying the range between a fifth and a sixth. Since we didn't know the range, we had first of all to look for that range. So, we first of all need to know which fraction is bigger. And I remember we had worked it out. If you want to know the fraction which is bigger, I said get the LCM of 5 and 6, which is 30. Multiply every fraction by the LCM, by the LCM, in order to identify the bigger fraction. Whenever you are to find which fraction is bigger, get the LCM, multiply every fraction by the LCM to find which fraction is bigger. So we can easily say a fifth multiplied by the LCM of 6 and 5 is 30. Multiply that this fraction by the LCM. Let me hope this is clear. This one we got it. By 5 once, by 5 is 6. 1 multiplied by 6, you get 6. So a fifth gives us 6. What if a sixth? Get a sixth, again also multiply it by the LCM. By 6 once, by 6 is 5. To me, hope there is clear. 6 goes into 30 5 times. So here we shall end up with 5. So which fraction is bigger? The one that gives a 6 or the one that gives a 5? You can compare which fraction is bigger. This is 6. 6 is bigger than 5. Meaning a fifth is bigger than a sixth. If you are to arrange in ascending order, ascending means you will start with sixth, comma, then a fifth. If it's descending order, meaning from the biggest to the smallest, you will start with now a fifth, comma, and a sixth. If they told you to arrange the fractions in ascending order. So we just wanted to know which fraction is bigger. That's why we multiplied every fraction by the LCM. So here we end up with a sixth is bigger than a fifth. 1 out of 5 is bigger than 1 out of 6. Why? A fifth gives 6. A sixth gives 5. 6 is bigger than 5. So the range, let's now find the range. Range is equal to highest, take away lowest. The range between those two numbers is get a fifth, take away first of, secondly, a fifth take away the second fraction, which is now a sixth. When you subtract LCM, already it is 30. Divide this 30 by 5, 6. 30 divided by 5. I told you these denominators. Just divide this there, LCM. 30 divided by this 5 is 6. Times 1 is 6. Take away. 30 divide this 30 by 6. 5 times 1, 5. Here you get 1 out of 30. Now, here we have just got the range between a sixth and a fifth. The range between a fifth and a sixth. Now, meaning the range is 1 out of 30. Now this question can be 1 out of 30 of a number is 7. I think the question can be reframed. 1 out of 30 of a number which I don't know is the same as equals 7. It is just like that. A 30th of a number, because a 30th was the range between those two fractions. A 30th of a number is 7. What is the number? What is the number? I think you can pick an idea from here. That's why we can say, let the number be x. Or you can even match. One part represents 7, whatever 30 parts. You can match or you let. We can say, let the number, write it in short, be x. Let the number be x. Now, when you get 1 out of 30 of, that is multiplied by, a number is 7. I've not done anything. We have just continued properly according to the question. Then here we shall have, can give that x a denominator 1, because every whole number has a denominator 1. 1 multiplied by x is x out of 30, which is equal to 7. Then from there, multiply both sides by 30 by 30, and you'll get your final answer. Let me erase here, complete it faster. So x out of 30, multiply it by 30, is equal to 7, multiply it also by 30. By 30 once, by 30 once. Our x alone here will give us multiply. When you multiply this, I know you'll get 210. Multiply, you can multiply it from our side. That is 0, that is 21, and that is it. So, what is the number? The number is 210. Thank you so much for listening to the corrections. We are going to head to the new work, my dear viewers. Let me hope, being a repetition, it must have been well understood. There is no need of rushing, and someone fails to pick a point. It will be very useless. Let's look at the new work. And due to time, we are likely to be a little bit... Okay. Wherever we shall end, we shall begin from there. Today we are just going to look at some few calculations about taps. Some few calculations about taps. We are still dealing with fractions. We are still dealing with fractions. The topic of fractions is a bit detailed. I told you we shall handle step by step. So let's look at a few questions about taps, and we see where time will push us. I've written here 2 questions. There are also other questions somewhere because of space. So some may have ever seen this, others may have never seen this. But even if you have ever seen or you have never seen, it is the highest time you paid maximum attention. Whenever you don't pay maximum attention, you don't understand. And you will keep disturbing. Teacher, I did not pick here. Why? Because the child was disturbing me. You can imagine. Because I was still washing utensils. So those lame excuses, please first spare some 30 minutes for this work. Even if you did it or you have never done it, it's the highest time we looked at it faster. Calculations about taps. Now, they are saying, tap A can fill a tank in 3 minutes, and tap B can fill the same tank in 6 minutes. Meaning there are 2 taps. Those 2 taps, when opened one by one, tap A takes 3 minutes to fill. It is a tank, that same tank. Tap A can fill the tank in 3 minutes, and tap B can fill the same tank in 6 minutes. Meaning, You open this one, it takes 3 minutes. You open the other one, it takes 6 minutes. It means there is one which pours more water than the other. Meaning the one which pours at a high rate happens to fill earlier than or faster than the one which pours at a lower rate. So we are going to look at just slight demonstration because of time. And we see how these taps can. I'm just going to sample. And you see the period of time these taps can take. I will use my clock. And we time ourselves. If they say tap A can fill a tank in 3 minutes, we are not going to base on this because this one is just like a demonstration. I've got the taps here. This is my tap A. And down here is my tap B. Now, tap A takes, we want to know what time does our tap A take to fill our tank. It can be a container. I've got a small container here whereby we are going to fill. When I open tap A, how long does it take to fill this container of mine? I will have to time. That's why I've moved with my clock here. My clock here is going to help me time well. If it is at 10, let me hope it will not land down again because it has already landed down. Good. So I will open my tap A here. So when I open tap A, I will have, let me first remove this. I've started, but it was at 7. How many minutes will it take? I want to see the time it will take to fill. Then when it gets filled, I will stop it. Maybe you may not see well. My tap is filled. My container has been filled. Because it was at 7, but it has filled when it is at 5. Now from 35 minutes to 15 minutes, how many minutes are those? We need to calculate. But I think it was not viewable by everybody. But we shall have also to see for tap B. It's just a slight demonstration. This one, I will now need to time to calculate the minutes it has taken my tap A to fill my container. It was at 7, but it got full when my minute hand was at 3. When I count the minutes, from 7 to 9, these are 10, 20, 30, 40. You see? Meaning, it took 40 minutes to fill my container. Tap A has filled my container in 40 minutes. What if tap B? I'm going to pour out that water and we see how long will tap B take to fill my container, same container. Now my tap B is down here. Let me hope you'll be in position to observe what will take place. Now, still, I will have to time. It's just a slight demonstration for you to achieve what I'm doing or what I'm meaning. So, it is, let me make it like that, so that everybody is in position to view. So, I'm going to open it when it is at exact, I've opened. So, it is now filling my thing. It is filling, I think there. People can view well, I think. It's not being viewed. We want to see the time that tap B of ours will it take to fill my container. Maybe people are, my tap is here. My tank is being, it's acting as a tank. It is my container. How long will it take to fill it? Tap A took 40 minutes. what if my tap B? How long will it take to fill my container? It started when it was at exactly 12. How many minutes will it take? It is still not yet full. Can show you. Not yet full. That is already 60 minutes gone. Not yet full. Yeah, it is full. If you can observe, my container is full, but it was at 10 minutes. Remember, it started from 6. By the time it got full, my minute hand was at 10, meaning it has taken 1 minute or 1 minute and is it 1 minute? 60 minutes. 60 minutes. Is it 60 minutes? When you count from here, how many minutes were they? Am I not talking a lie? From here up to here, you know how to count. In fact, they were not minutes, seconds. They were seconds, not minutes, sincerely. Because this is our second hand. This is our hand for the seconds. This is our hand for the minutes. This is our hand for the hour. Had misinterpreted it, and it's very good to analyze back. So this is our the hand for the seconds. The moment it rotates and goes back to 12, it would have made 60 seconds. Now 60 seconds are equivalent to 1 minute. 60 seconds are equivalent to 1 minute. The first tap, let me remove it now. The first tap took 40 seconds, not 40 minutes, like they had counted. The first tap took 40 seconds. The second tap, that is tap A. Tap B took, it rotated from 12 back to 12. That is a full minute. Those are 60 seconds, which make up a minute. Then it added on some 10 seconds, meaning it was 70 seconds. Now 70 seconds, if I write 70 seconds, let me write 70 seconds so that they are all in seconds. Meaning, between tap A and B, there is one which powers at a higher rate than the other. Tap A filled my container in 40 minutes, but tap B filled my container in 70 minutes. Meaning, these two taps power at a different rate. This one powers at a higher rate than this one. See that? So those taps may not fill your container at the same time, depending on the volume which is powered. So that's what I wanted to show you. But if they say, if all are opened at the same time, how long will they take to fill the tank? Will they take 40 minutes? Will they take 70 minutes? They are all opened at the same time. How long will they take to fill our tank? Now that's what they normally ask. So I thought this is a slight demonstration so that you don't just picture what I'm talking of. When you're talking about taps, they can talk about even pumps of petrol stations, like that. So I wanted to bring it so that you can really see the image I'm talking of. Let me now open at the same time and we see how long it will take. Now, let me hope you'll be a little bit keen to see that you observe what is taking place. I'm going to wait so that this is my second hand of the clock. Minute hand, hour hand. When it clocks 6, I will tune on. And I see both of them at the same time. I've opened them at the same time. How long will they take to fill the tank? It is getting full. Yeah, it is full. It is full. But it was at 7. You can imagine. My minute hand was exactly at 7. From 12 to 7, those were 35 seconds. Those were 35 seconds. So what do I mean? If tap A and B are all opened at the same time, they fill my container in only 35 minutes. You see that? Now, according to the rates, I just want you to have a small idea about this. If they are all open at the same time, you know, they may not be very full, not both of them are full, depending on the situation. You realize when tap A and tap B are opened at the same time, they are all pouring in the same container at the same time. You will find that they will take fewer period of time than one by one. You see that? So you open them at the same time, they begin pouring, this one is pouring, this one is pouring, they are competing. Within a little period of time, the container will be full. Meaning when you open both taps at the same time, they will take a little period of time as compared when it's one by one. So this is what we are going to deal with. That's why tap A took almost 40 seconds, tap B took 70 seconds. But now when you open them at the same time to fill the same container, you'll find that it is around there. It may not, but it is around there. But still when you compare, you realize that the 30 minutes are less than n of these two. You see that? So this is what we are going to calculate according to our questions here. That was just a simple demonstration to show you that when they are open at the same time, they will fill the tank or the container within a lesser period of time than when it's one by one. The period reduces. So we are going into calculations for these questions, and we see the way forward. Introduction may not have been easy, but the rest will flow very well. So that was that. I pour out my water. So these were my taps and my container. I had to create this. This is one tap, which was filling my container, and this was another tank. So these were two of them that were filling. If you don't know how to make one, you can make one for hand washing at home for sanitizer. You pour there the sanitizer and you work out well. So that was that. We wanted to have just a brief idea about how these taps work. Otherwise, doing it theoretically, you may not imagine what these taps are. So the rest we can discuss and we talk. So we are going to answer our number 1. So the time we have written there, or you have been getting, may not be very accurate because the rate was not well timed. But that was a slight demonstration to know what we are talking about when we talk about taps. And these questions are very examinable. I've ever met in one in 2015. It was around number 30. Number 30 in 2015, if you can pass through your past PLOE papers. It was around number 30 in 2015. So you need to have that idea so that they can help us work out these numbers. Let's start off with the working out our number 1. If tap A can fill the tank in 3 minutes, and tap B can fill the same tank in 6 minutes, how long will both taps take to fill the tank if they are opened at the same time? Now, dear viewers, we start off. Now, it is not easy to tell. What we shall do, we shall need to know what fraction of the tank is filled within only, first of all, 1 minute. You see that? Meaning, first of all, get the fraction of the tank that can be filled in 1 minute. Meaning, your tank can be divided into 3 equal parts. If this is your tank, let me draw it here. Can be cylindrical tank. You divide it into 3 equal parts. Then there it is full. It gets full within only 3 minutes. Meaning, in every minute, A third of the tanker is filled. A third of the tanker. Now, you need to divide your whole tanker into 3 equal parts, so that in each minute, 1/3 is filled, another one is filled, another one is filled. By the end of the 3 minutes, a third plus a third plus a third, there will be 3 minutes. And your whole tanker will be full. That is it. Tap A. You can say in 1 minute. In 1 minute, you can put a comma. Tap A. Tap A fills what fraction of the tank? It will fill now this one. Your tank should be divided into 3 equal parts, so that in each minute, 1 part is filled, another part is filled, another part is filled. Let me maybe remove this so that you can really see up to the top, up to the brim. Eh? So in 1 minute, this one is filled. This is a third. So it is a third, a third, a third. Like that. So each is a minute, a minute, a minute. By the end of the 3 minutes, because a third plus a third plus a third, you will get 1 whole. The whole tanker will be full. So in 1 minute, tap A fills, it will fill 1 part out of 3 parts of the tank. Now, if tap A fills, in 1 minute fills a third. What if tap B? Tap B, still in 1 minute, tap B fills. It will fill now what? For it, it fills the whole tank in 6 minutes. Meaning, your whole tank can be divided into 6 equal parts. So, we shall divide this into 6 equal parts. 1, 2, smaller one, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Up to the top, to the brim here. So I've divided my whole tank into 6 equal parts. So that in each minute, 1 part out of 6 parts is filled. This is 1, 2, 3, 4, 5, 6. In every minute, a 6 is filled. A 6 is filled. A 6 is filled. You see that? In 1 minute, a 6 of the tank will be filled. Now this is step B. It will, you need to divide the same tank into 6 equal parts. So that this one, in 1 minute, it is a 6 which is filled. A 6 which is filled. By the end of the 6 minutes, the whole tank will be full. Why? Each A6 is a minute. Each A6 is a minute. It fills each A6 in 1 minute. These are 6 of them. 1, 2, 3, 4, 5, 6. When you get A6 times 6 of them, you will get 1 whole. Or when you add A6 plus A6 plus A6 plus 6 times, you will get still 1 whole, meaning the whole tank will be full. So in each minute, A6 is filled. A6 is filled. A6 is filled. A6 is filled. By the end of the 6 minutes, the whole tank will be full. Now, meaning in 1 minute, it fills this. Now, since both taps are going to be opened at the same time, this fraction of the tank will be filled in 1 minute. And also for the other one, which fills the whole tank in 3 minutes, this fraction will be filled. Now, we shall divide the same tank into 6 equal parts. And you see what fraction will be filled. I will divide this way, 1, 2, 3. I will make sure that 6 parts also come from here. I will divide this one into 2. 1, 2, 3. Same tank. Remember, this was a third. Now this is a 6th. A 6th. A 6th. A 6th. A 6th. A 6th. Each is a 6. 1, 2, 3, 4, 5, 6. You see that? You get the point. Now, this, remember, from here up to there was a third. Now, in 1 minute, remember, since they are all pouring in the same tank, tap A pours a third, and the tap B, for it, it pours a 6. Now, in the same minute, this 6 gets added to the third which is there. You see that? How? Let me hope something has been taken. If tap A fills, they are all pouring at the same time. This one is also pouring at the same time. Same minute. In 1 minute, tap A fills a third, as tap B fills a sixth. Now this is our fifth. Let me put like this. I've put XX. This was for a third, tap A. Then tap B must have also added on a third D. Is it? No, not a third, a sixth C. See that? Meaning, when they are all pouring at the same time, the tank will be at that level. At 1 minute. 1 minute like this, the tank will be filled up to that level. A third plus a sixth. That is why we say tap B fills 1 out of 6 of the tank in the same minute. And therefore, let me rub this. It was just for demonstration for you to see. This axis will be added in the same minute here. And you see where the tank will be. Meaning, in each minute, the tank will be at that level. Another minute, the tank will be at that level. And you find how long will the whole tank take to be filled. So, both in 1 minute, both fill. We are now going to find the total fraction. Both fill, we shall get a third. The fraction filled by tap A plus a sixth. The fraction filled by tap B. So this working is just to enable you see what really takes place. So in 1 minute, a third was filled. In the same minute, not 2 minutes, in the same minute, a sixth was filled. So what was the total fraction of the tank which was filled in only 1 minute? So is what we are finding here. So here, when we add, both fill, LCM here will be, is it 6? 6 divided by 3 is 2. 2 multiplied by 1 is 2. Plus 6 divided by 6 is 1. 1 multiplied by 1 is 1. So when you add that, it will be 3 out of 6. We can reduce this to the lowest term. By 3 once, by 3, 2. To me, I hope I'm not very fast for this case. The demonstration has taken some time, but we are now continuing. I think this one is easier to grasp. So that means a half of the tank is filled in only 1 minute when both taps are opened at the same time. Let me draw here these 2 bars to show that I'm going to the right. So this is a half. Meaning, in only 1 minute, a half of the tank is filled. Meaning, every minute, a half is filled. Then another minute, the whole tank will be full. Meaning, you can easily get the whole tank now. You divide it into halves. Because each 1 out of 2 is a minute. Each 1 out of 2 is a minute. That is why we normally just get the whole tank. You divide it into 1 out of 2. How many 1 out of 2s are there in the whole tank? You see this? How many 1 whole divided by a half? It means 1 divided by a half, or 1 out of 2. This one simply means how many 1 out of 2s are there in the whole tank. Remember, each 1 out of 2 is a minute. Each 1 out of 2 is a minute. You see that? So here we shall now have 1 out of 1 multiplied by now 2 out of 1. You understand that when the division changes to multiplication, we get the reciprocal of the second fraction. So this is 1 out of 1, which is just 1. Multiplied by, we now get the reciprocal of 1 out of 2, which is 2 out of 1. And here we end up with 2. Now what are these? These are minutes. Because the period was in minutes. If it is minutes, write minutes. If it is in hours, write hours. If it is in days, write days, please. Check the units. Meaning the whole tank will be filled in only 2 minutes. What does this mean? There were only 2 halves in the whole tank. Each half is a minute. Each half is a minute. You can even prove from here. 1, 2, 3. That's 1 minute. 1, 2, 3. This is another minute. This will also be filled. In 2 minutes, the whole tank will be full. That is the issue with this glass. So, if there is something which has been picked here, well and good. Number 2, we shall calculate it faster. One tank is filling and another one is emptying or removing. Let me hope this one is well understood. You will keep practicing from home. Allow me rest here. If I'm a bit faster, we are still continuing with the same topic, I know. If you have not picked somewhere, you will pick as we continue. Now our number 2. Tap P takes 3 minutes to fill the tank. And tap Q takes 4 minutes to draw water from the tank. We are going to use the same technique we have been using to answer the same question. So if tap A fills the tank, tap P takes 3 minutes to fill the tank, and tap Q takes 4 minutes to draw water from the tank, how long will it take to fill the tank if both taps are opened at the same time? If both taps are opened at the same time. Still the same thing, we shall now arrange. Since they are talking about minutes, we shall first consider what fraction of the tank will be filled in only 1 minute. And what fraction of the tank will be removed from the tank in also 1 minute. Meaning at the end of 1 minute, there will be some water which is left in the tank. Now the technique here is, you'll find that the tap which is filling fills at a higher rate than the one which is removing. That is why when the tap which is filling fills very fast, the one which is removing will leave some water in the tank. And that water will continue to accumulate in the tank. Will continue to accumulate in the tank like that. See that? So we shall still say in 1 minute, still I will put those semicolons. Tap P. Tap what? P fills. Now, the tank will be still divided into 3 equal parts, so that in 1 minute, tap P fills 1 part out of 3 parts of the tank. I think that is clear. Tap P fills 1 part out of 3 parts of the tank. That is tap P. While tap Q draws or empties, draws. Now, for it takes 4 minutes to draw water from the tank, meaning it takes a little bit longer period of time than tap A. Meaning you need to divide the whole tank into 4 equal parts, so that in each minute, a quarter of the tank is removed of the tank. Tap P fills a side of the tank as tap Q removes a quarter of the tank in the same minute. You see that? So, when this one fills this and this one removes this, at the end of 1 minute, there will be some little water left in the tank. Now that water will continue accumulating like that, until the whole tank gets full. So we shall have both now. At the end of 1 minute, I will now use this. Both will fill. Why? Because this one was filling, this one was drawing. By the end of 1 minute, there will be some water left in the tank. Why? Because tap P was filling at a higher rate than tap Q. See that? Now at the end of the minute, there will be some water which will be left in the tank. Now that's the water which will continue to accumulate in the tank until the tank gets full. So we shall say, both will fill, we get a third. Take away. This one is the one which was filled. We shall remove the one which was removed. Remember, the other one, both of them were filling. That's where we added both. But this one is filling, another one is removing. So we get a third which has been filled. Take our quarter. You see that? Then we see what fraction of the tank will be left in the tank by the end of 1 minute. Boss will fill now LCM here. It is 12. 12 divided by 3 is 4. 4 multiplied by 1 is 4. Take away. We're taking away because 1 was removing. Take away 4. 12 divided by 4 is 3. 3 multiplied by 1 is 3. So here we shall end up with 1 out of 12. Meaning, this one is the fraction of the tank after 1 minute. The tank will be at 12 full. Meaning, ever after 1 minute, the tank will be at 12. The tank will be at 12. Meaning, we need now to divide our tank into 12 equal parts. Into 12 equal parts. So that each minute at 12 is filled. That is why we normally say, just get one whole, the whole tank, divide it into 1 out of 12. How many at 12s are there in the whole tank? So here we shall now have 1 out of 1 multiplied by. Now, when the division changes to multiplication, you get the reciprocal of the second fraction. This will be 12 out of 1. So here we shall end up with the 12. Were they minutes? Yes, 12 minutes. Meaning, when the tank the tank will be filled in 12 minutes. When one tap is filling and another one is drawing, the tank will be filled in 12 minutes only. And that is that. Our time is used up. We shall have to look at more. Maybe on Friday, slowly by slowly. We shall not be cut off. Is it clear? I think this is that. My dear viewers, due to time, our time is used up. But that's what to do. I would leave with you some assignment, but due to time, I can't. Take through your papers past PLOE. You will get them. We shall add on next time. I wish you a lovely morning. May God bless you. Sava Saja Kabaka Awangale.